Okay, so we're going to kind of change gears from algebra to trigonometry. So trigonometry is basically an extension of geometry with like triangles and squares and circles and all that. We're going to go into trigonometry, and trigonometry really mainly deals with circles and triangles. So let's kind of get started. Before we first get started with actual trigonometry, we need to talk about angles and their measure. So when we measure an angle, we have basically two rays, and the measurement of the angle is from one side to the other. The side that we first start with is called the initial side, and we're measuring to the terminal side. Okay? And there's several different ways of measuring. We can measure this direction, or if we measure down, and this one is our initial, and this one is our terminal, when we go backwards, that is in a clockwise manner, that would be a negative angle. And we can also go in a counterclockwise manner, and it's still a positive angle. We could even have an angle where we measure all the way around and come back to this guy. They keep going in circles like that. Okay, so let's start with a grid here. If we start on this line right here and say that's our terminal side, if we have an angle that goes across there that we want to measure, the usual measurements we use are between 0 and 360 degrees. So this would be 0 degrees. This would be 90 degrees. This is 180. This is 270. And then when we go back to 0, it's 360 degrees. And it keeps going. Okay? So this shouldn't be new to you. You should be, know how to do this. But in trigonometry, we don't always use degrees. We use a different measurement called radians. Okay? Now, let me talk about what radians are, and then how do we convert from degrees to radians. So if we look at the circle again, oops. When we start at 0, it's still 0 radians. Okay? In a full circle, there is 2 pi radians. Okay, and this relates to the circumference of a circle, is why pi comes in, because we use pi to find the circumference of a circle. 2 pi radians. Okay, so then some of these other measurements, if we go like half away, half of that would be pi, that'd be 180 degrees. Half of that would be pi over 2, which is 90 degrees. And then down here at 270, that's 1.5, or 3 pi over 2 is 270 degrees. Okay? So if you wanted to split some other ones here, that's 45 degrees. You would just split that guy in half, which would be pi over 4. Okay? Radians. So I'm going to draw another circle here in a second just to show some more of them, but that's how radians work. And we always use radians in trigonometry instead of degrees, because degrees is based on something different. Radians are actually based on actual physical measurement. Like if you have a radius of so many inches, the radians would actually be proportional to that, because it's based on actual measurement of circumference. So, how do we convert from degrees to radians? Well, I told you that there are 2 pi radians in 360 degrees. So, if you know that there's 2 pi radians in 360 degrees, if you simplify that, that would give you pi over 180 radians to degrees. Okay? So, if you want to convert, you'd flip that to find the other one. So let's say you have theta, instead of x, we'll use theta, degrees. To convert that to radians, you would flip this at 180 degrees to pi radians times theta. Okay? If you have theta radians, this is going to be changing it to radians here. If you have theta radians, that's going to be, like I did up there at the top, pi over 180 theta in degrees. That's how you convert from one to the other. So, let's convert some major angles that we know, and then let's convert some weirder angles. So let's start with between 0 and 90 degrees. Here's 90 degrees. Here's 0. Well, 0 degrees is 0 radians. We don't have a symbol for radians. We just write out the number. Okay? I already told you that if we want to find 45 degrees, that would just be pi over 4. That'd be dividing that, dividing pi over 2 by 2 again. Okay. Let's look at 30 degrees. Using our conversion from this page, we're going to use this guy. Okay. So that's going to be 180 over pi times 30. Hold on. I need to be using this one down here, because I'm trying to convert it to radians. So I need to plug in on the bottom equation. That's my fault, I'm sorry. So we have 30 degrees. So that's going to be 30 times pi over 180. And then 30 over 180 simplifies to just 1 over 6. So it is pi over 6. So 30 degrees is pi over 6. Let's look at 60 degrees. This will be 60 times pi over 180, which simplifies to pi over 3. So 60 degrees is pi over 3. Okay, let's look at 20 degrees. It's down here. That's 20 times pi over 180, which gives you pi over 9. Okay, so on and so forth. Looking at some weirder angles, say let's find 75 degrees in radians. That's 75 times pi over 180, which simplifies to 5 pi over 12. Okay, say we do want to convert from radians to degrees. Say we have pi over 16 in radians. So that would be flipping this guy, be pi over 16 times 180 over pi. The pi's cancel, and then 180 over 16 is 45 over 4, or approximately 11.25 degrees. Okay, so that's basically all you do. We have to use radians instead of degrees whenever we're doing these guys. Okay?